Okay, welcome to today's topic, that is utilities, electricity and static electricity. So utilities, what are the utilities are using in industry, that we are going to discuss in details. So electricity is an essential utility. Electricity also one of the essential utility in our daily lives and forms the backbone of modern civilization. From lighting our homes to powering industry, its role is indispensable in this unit. So we will explore the concepts of utilities with a focus on electricity, including its generation, right? How the electricity is used. Uh, a, spe- uh, a special focus will also be given to static electricity. It is a fascinating phenomena where electric charges build up on the surface of materials, right? So let's get started of this unit, this topic. So introduction to utilities in process safety management. So how utilities are important in industries. Okay. So utilities in process industries refers to essential services um, such as electricity, water, steam, compressed air, and inert gases that support safe and efficient operations. So proper management of utilities is critical to maintaining process safety and preventing accidents, right? So I explained this introduction in detail, okay, right? So what are the utilities generally we have in industries? So as electricity, water, steam, compressed air, inert gases. So these are main supporting systems. These are the utilities are crucial for ensuring safe and efficient operations, right? So in industrial settings, especially chemical, pharmaceutical and oil gas plants, utilities are services or resources that support the main production processes. So though they are not always part of the final product, they are crucial for the operation, control and safety of the plant. So electricity. So powers equipment, lighting, control systems and more. Critical for automated systems and safety alarms. Water. Used for cooling, cleaning, steam generation and sometimes as a raw material. Used for cooling, cleaning, steam generation and sometimes as a raw material. So cooling water systems are essential to avoid overwhelming, which can lead to fires or explosions. Next, coming to steam, commonly used for heating, sterilization and power generation. Steam systems must be properly maintained to avoid pressure related hazards. Compressed air powers pneumatic equipment, instruments and valves. Contaminated or insufficient air pressures can cause operational failures, right? Inert gases like nitrogen used to prevent fires, explosions by displacing oxygen in tanks and pipelines, inerting or blanketing, also used for purging equipment safely. So why utilities matter in process safety, that is process safety management. So process safety management focuses on preventing the unintentional release of hazardous substances and ensuring the safety of workers and environment and equipment. So utilities play a supporting but vital role in this by maintaining control, preventing hazards, ensuring continuity, supporting emergency systems. So in summary, while utilities may seem secondary, they are essential to the safe and efficient functioning of industrial processes. So poor management of these utilities can lead to equipment damage, process failures, and even catastrophic accidents. So that's why process safety management programs must include detailed procedure for the design, monitoring, and maintenance of utility systems. Okay, I hope this introduction is enough for utilities and process safety management. Next, coming to objectives of utility management in process safety management. So what are the objectives we have? So ensure reliable and safe operation of utility systems. So utilities such as electricity, water, steam, and compressed air must be continuously available and function correctly. Any interruptions or malfunctions can halt operations or create unsafe conditions. For example, if cooling water fails, it can lead to overheating and cause pressure buildup or fires. Prevent hazards associated with utility failures. So, utility failures can lead to serious safety incidents like fires, explosions, toxic releases, or equipment damage. Example, failures of inert gas supply in a flammable storage tank can allow oxygen in, increasing the risk of explosion. Failure of inert gas supply in a flammable storage tank can allow oxygen in, increasing the risk of explosion. So maintain compliance with industry safety standards. So regulatory bodies like OSHA, EPA, etc. have guidelines and standards for how utilities should be managed in industrial settings. Regular maintenance inspections and monitoring help companies avoid violations and legal penalties. Reduce environmental and operational risk. Leaks, spills, or emissions due to poor utility management can harm the environment. So efficient utility management helps reduces waste, minimizes downtime, and improve overall process reliability and sustainability. So ensure reliable and safe operations of utility systems. That is one of the objective. Second objective, prevent hazard associated with utility failures. Third, maintain compliance with the industry safety standards and reduce environmental and operational risk. So these objectives ensure that utilities support process safety by being reliable, risk-free, legally compliant, and environmentally responsible. So effective utility management is a backbone of safe and sustainable industrial operations. Safe and sustainable industrial operations. I hope this objectives you understood. Next we will go to next slide. That is types of utilities in process industries. So what are the types we have? First one is electricity. As all of us know, electricity provides power for equipment, lighting, control systems, safety devices, right? So importance in safety ensures continuous operation of safety systems like alarms and emergency shutdowns. Powers instrumentation critical to monitoring pressure, temperature, chemical processes, right? And also in risk management, strict safety protocols are needed to prevent electric shocks to personnel, short circuits which can damage equipment, electrical fires which can lead to severe accidents or plant shutdowns. So risk management also we must have, right? So purpose is to power the equipment, lighting, control systems, and safety devices across the facility. Yes, we can understand. But the stringent safety measures to prevent electric shocks, short circuits, and fires, which means importance in safety is important. Ensure safety, continuous operation of safety systems like alarms, emergency shutdowns, right? Powers instrumentation critical to monitoring pressure and temperature and chemical processes. Risk management, strict safety protocols are needed to prevent electric shocks to personnel, short circuit which can damage equipment, electric fires which can lead to severe accidents or plant shutdown. Water supply and management uses, so cooling systems to prevent overheating of reactors and equipments, steam generation as feed water, cleaning and fire protection, that is sprinklers and hydrants we can use, right? That is the uses of water supply and management. So water treatment and needs, what are the water treatment and needs? So prevent scaling which clogs pipes and reduces heat transfer efficiency, avoid corrosion that can weaken pipes or tanks, control biological contamination like algae, bacteria which can affect process quality or block systems, right? So steam generation and distribution. So functions, what are the functions? Provides heat for reactors and distillation columns, drives turbines for power generation, enables precise control of temperature and pressure in many processes. For the safety requirements, we have boilers must be properly designed and regularly maintained. Boilers must be properly designed and regularly maintained. Regular checks help prevent overpressures, explosions, right? So each of these utilities plays a foundational role in both the operation and safety of a process industry. So managing them correctly ensures efficiency, safety, compliance, and environmental protection, right? I hope you understood the types, and I will discuss more types in further. Okay. So we have again we have a number of types. So what are the other types we have? So we'll discuss. So compressed air systems. So we have compressed air systems. Sorry for the gap. Wait a minute. I'll continue. Okay. Sorry for 1 minute gap. So not 1 minute. Maybe 20 or 30 seconds or 10 seconds. Okay. I'll start. Compressed air systems used in pneumatic tools, instrumentation, and control systems. Requires moisture and contaminant removal to ensure efficient operation. Inert gases like example nitrogen, argon, carbon dioxide, right? So pneumatic tools means what? Examples are valves, actuators, we call these as pneumatic tools. Drives, instrumentation and control systems where electrical devices may not be safe, especially in flammable or explosive environments. So what are the importance? So compressed air is a clean, reliable source of energy for automated systems. Safety and efficiency measures. So must remove moisture to prevent corrosion in pipes and equipment, must filter out contaminants like oil and dust to ensure precise control and avoid damage to sensitive components, right? Next, coming to inert gases, nitrogen, argon and carbon dioxide. So functions, what are the functions of inert gases? First one is blanketing. Blanketing means forms a protective gas layer over flammable or reactive liquids to prevent contact with oxygen. Purging displaces air, oxygen or hazardous gases from pipelines and vessels before startup or maintenance. Fire suppression reduces oxygen concentration in an area to prevent or extinguish fire. So examples, nitrogen is widely used due to its availability and inert nature. Argon is used in welding and high purity applications. Carbon dioxide is used in fire suppression systems. So hazards. So improper handling can lead to asphyxiation. Asphyxiation means since these gases can displace oxygen in confined spaces. So requires well ventilated storage areas and use of oxygen sensors for workers' safety. Okay. So utilities we have seen electricity, water supply, steam, compressed air, inert gas, so far. So electricity main uses is power control safety devices. The safety concern is that electric shocks or fires. Water supply mainly used for cooling. See, we are discussing one by one again. It's okay. Cooling, cleaning, fire protection. What are the safety concerns in water supply? Scaling, corrosions. And steam, what are the uses? Heating, process control. And safety concerns, overpressure or explosions. So compressed air, what are the uses? Pneumatics, instrumentation. What are the safety concerns? Moisture, contamination. Inert gases, what are the main uses? Blanketing, purging, fire suppression. So safety concerns, asphyxiation. Asphyxiation, right? What is asphyxiation? These gases can displace oxygen in confined spaces. Okay. So next we are moving to another cooling systems, fuel supply. Okay. So cooling systems that are cooling water, refrigeration, air conditioning, right? So what is the purpose? Maintain optimal process temperature to ensure chemical reactions or equipment stay within safe operating limits. Prevent overheating of equipment such as compressors, turbines and reactors. So components we have cooling tower, chillers, air conditioners and refrigeration units depending on the temperature requirements. Temperature requirements. So what are the components? Cooling towers, chillers, air conditioners and refrigerator units depending on the temperature requirements. So we have safety and maintenance requires regular inspections to check for leaks, scaling. So deposits that block heat exchange and corrosions. So improper cooling can lead to thermal stress. Improper cooling lead to thermal stress and equipment and inefficiency in operations. So essential for maintaining processes temperature and preventing overheating requires regular maintenance to avoid leak, scaling and efficiency losses, right? So safety and maintenance components and purpose we have discussed. What is the purpose? Maintain optimal process temperature and prevent overheating. What are the components? Cooling tower, chillers, air conditioner. What is safety and maintenance? Regular inspection to check for leaks, scalings, and corrosions. Now coming to fuel supply, generally we use nitrogen gas, natural gas, LPG, hydrogen, etc. What is the purpose? Fuels are used for combustion purposes, processes such as heating reactors, generating steam or running power generators. So hazards, these are flammable gases and leaks can lead to explosions or fires. What are the safety measures? Requires leak detection systems like gas detectors and alarms. Must follow safe handling and storage protocols. Equipment like pressure regulators, flame arresters and ventilation systems must be in place. Right? So purpose is fuels are used for combustion process. such as heating reactors, generating steam, or running power generators. What is the hazards? These are flammable gases and leads can lead to explosions or fires. What are the safety measures we have? Requires leak detection systems like gas detectors and alarms. Must follow safe handling and storage protocols. Equipment like pressure regulators, flame arresters, and ventilation systems must be in place. So, keeping the entire industrial operation thermally stable, ensuring a continuous energy supply. So, avoiding safety risks like fire, explosion, or overheating is very important, right? These are the important steps, right? We'll go through once the slides. So, okay. Again, if you have any doubts, you can ask me online or offline. Take notes when classes are going, okay? And uh, don't stay that unlistened, okay? Just listen carefully and study. Okay. Okay, next we will go to next slide. That is electricity in process safety management. So we have discussed so far what are the utilities we have, and the next we are going to discuss about electricity in process safety management. So what are the important aspects we will discuss? So electricity is a vital utility in process industries, but it also poses a significant risk, including electrical shocks, short circuit, arc flashes, and fires. So, what are the electrical hazards in process industries? Electric shock, arc flash, overloading circuit, and faulty groundings. So, electricity powers equipment, lighting, control systems, and safety devices, making it indispensable in process industries. However, electricity also introduces serious risks such as electric shocks, short circuit, arc flashes, and fires. Right. So, electrical hazards in process industries, we have electric shock occurs when a person comes into contact with the live electrical parts, can cause serious injuries or even fatalities. Safety measures power proper insulation, use of personal protective equipment, PPE, and lockout tagout procedures Arc flash, a sudden release of electrical energy through the air due to a fault. So produces intense heat and light, causing severe burns, fires, and equipment damage. So prevention includes ARC-rated PPE, safe work procedures, and protective devices. Overloading circuits happens when electrical systems draw more current than they are designed to handle. So results in overheating, which can lead to fire hazards or equipment failures. So managed by circuit breakers, load management, and regular inspections. Faulty grounding. Grounding ensures electrical systems are safe by providing a path for stray currents. Over or missing grounding can increase the risk of electrocution and equipment malfunction. So prevention involves ensuring proper grounding systems are in place and routinely tested, right? So these are the electrical hazards in process industries, right? Okay. So electricity is essential but potentially dangerous in process industries. So understanding and managing electrical hazards is crucial for protecting human life, preventing equipment damage, maintaining process reliability and safety, right? So electricity in process safety management is very important, right? Because without electricity powering the equipments and lighting control systems and safety devices, so making it indispensable in process industries, right? Anyway, it causes some serious risks such as electrical shocks, electric circuit, arc flashes, and fires. And what are the preventive measures we have discussed, right? For this, okay, we'll continue next slide. So, what are the electrical safety measures we have? So, proper grounding and bonding. So, ensuring all electrical equipment is properly grounded to prevent electricals, that is shock hazards. Proper grounding and bonding. Ensuring all electrical equipment is properly grounded to prevent shock hazards, right? So next, use of explosions proof equipment required in hazardous areas where flammable gases or vapors might be present. So prevents ignition sources from causing explosion. Prevent ignition sources uh, from causing explosions. The regular maintenance and inspection involves a scheduled checks to identify and fix potential issues before they become serious problems. Ensure the system remains in safe working conditions. Personal protective equipment includes insulated gloves, rubber mats, and arc flash suits. Protects workers from shocks, burns, and arc flash injuries. Lockout, tagout, LOTO. A crucial procedure that ensures equipment is de-energized before maintenance and work begins. So prevent accidental energization and injuries. So these practices form the foundation of electrical hazard control in process plants, right? So these are the electrical safety measures, that is proper grounding and bonding, use of explosions proof equipment, regular maintenance and inspections, personal protective equipment, lockout, tagout procedures. Okay. So next we are moving to that is static electricity in process safety management. So what are the static electricity in process safety management? So static electricity is the accumulation of electric charge on a surface due to friction, separation or induction. So in process industries, uncontrolled static discharge can ignite flammable materials, leading to explosions and fires. Leading to explosions and fires. So static electricity is the accumulation of electric charge on surface due to friction, separation or induction. So in process industries, it poses a serious fire and explosion hazards by igniting flammable materials. What are the common sources in process industries? Flow of liquid and gases. So especially during the movement of hydrocarbons, chemicals or powders through pipelines, friction between particles and pipe walls build up static. Friction between surfaces. So contact between non-conductive materials like rubber components or conveyor belts. Tank filling and draining. So rapid transfer of liquids can generate high static charges. Synthetic clothing and footwear. Synthetic materials can generate sparks through charge buildup on workers. So, common sources in process industries that include the flow of liquid and gases, sometimes powder also, right, through pipeline. That friction between particles and pipe walls build up static. Friction between surfaces. So, contact between non-conducive materials like rubber components or conveyor belts. Right. Next, tank filling and draining. Rapid transfer of liquids can generate high static charges. Synthetic clothing and footwear. Synthetic metals can generate sparks through charge buildup on workers. Right. So these are the common sources in process industries. Okay. So next we are moving to next slide, that is control measures for static electricity. So what are the control measures we have for static electricity? Just 1 second. So control measures for static electricity, we have proper grounding and bonding, use of anti-static additives, controlled filling rates, use of conductive flooring and footwears, and humidity control. So what is proper grounding and bonding? So this is what we have discussed earlier of this session. Okay. So connecting conductive materials to a common ground to dissipate static charges, bonding of containers and pipelines to prevent charge buildups, right? Okay. Um, Use of anti-static additives, adding conductive additives to flammable liquids to reduce charge accumulation. Okay. So proper grounding and bonding. Grounding means connecting all conductive materials like metal tanks, pipes to a common ground to safely discharge static electricity. So bonding involves linking containers or pipelines to each other to prevent charge buildup when transferring materials. So use of anti-static additives. These are special chemicals added to flammable liquids to reduce the buildup of static electricity during handling or processing. Controlled filling rates. Filling tanks too quickly can generate a lot of static electricity, so slowing down the filling rate helps minimize this risk. So use of conductive flooring and footwear. Workers are provided with anti-static shoes and work in areas with conductive flooring to prevent dissipate any static charge safely, reducing the spark risk. So humidity control. Dry air allows static charges to build up more easily. Maintaining adequate humidity in the environment helps reduce this accumulation, right? So grounding and bonding is very important. Anti-static additives we have to use. Controlled filling rates. So that is filling tanks too quickly can generate a lot of static electricity. So controlled filling rates is very important. Use of conductive flooring and footwear. Workers provide with anti-static shoes and works in areas with conductive flooring to help dissipate any static charge safely. And humidity control. Dry air allows static charges to build up more easily. Okay. So these measures are important in industries dealing with flammable materials like chemicals or gases because static electricity can cause sparks which may lead to fires or explosions. Fires or explosions. Okay, next we are moving to next slide, that is emergency response and mitigation strategies in electricity, static electricity. So electrical safety training, fire protection system, monitoring and detection systems, and emergency shutdown procedures are very important in emergency response and mitigative techniques. So electrical safety training, regular training for personnel on safe handling of electrical and static electricity hazards. Yes, we need to give a regular training for personnel on how to handle safe electrical and static electricity hazards. That is very important, right? And fire protection system, yes, we need to have a good fire protection systems, installing explosion proof electrical equipment and fire suppressor system high risk areas, right? And monitoring and detection systems um, using sensors to detect static charge buildup and prevent uncontrolled discharges. Emergency shutdown procedures, implementing quick shutdown mechanisms to isolate electrical faults and prevent escalations, right? Right. So, like this, we have emergency response and mitigation strategies. So, all these emergency response and mitigation strategies helps from helps from all these electrical and fire injuries. Okay, and electrical and static electricity problems, accidents. Okay, so just uh, I need to give you more on this emergency response and mitigation strategies. Okay, I'll give you one by one. I just that is not sufficient, so I am explaining elaborately more again, again once again. So electrical safety training, this means teaching workers how to safely deal with electricity and avoid dangers like electric shocks or fires. It's about knowing the right practices and being careful around electrical equipments. Fire protection systems. So this involves setting up special equipment that can prevent or stop fires, especially in places where there is a high risk, like where flammable metals or powerful machines are used. So it includes things like fire extinguishers, alarms, and fire-resistant materials. Monitoring and detection systems. These are smart sensors that keep an eye on electrical systems to catch problems early like static electricity building up. If they detect something wrong, they can alert the team before it becomes dangerous. Emergency shutdown procedure. This is a plan for quickly turning off machines or power when something goes wrong to stop things from getting worse. For example, if a machine starts sparking, it can be shut down fast to prevent a fire or explosion, right? I think this discussion is enough for this. So now coming to conclusion of this class, okay. So proper management of utilities and electricity and static electricity is essential for maintaining process safety in industrial environments. Implementing robust grounding, bonding, and electrical safety practices helps mitigate risk, right, associated with electrical hazards and static discharges, ensuring safe and efficient plant operation. So I'll break down this conclusion one by one. First one is proper management of utilities, electricity, and static electricity. So this means you must handle electrical systems carefully and plan for potential dangers, and especially in factories or plants. It is essential for maintaining processes safety in industrial environments. Yes, if electricity is not managed well, it can lead to accidents. Safe electricity practices help avoid those risks. Implementing robust grounding, bonding, and electrical safety practices. Yes, grounding and bonding are techniques used to safely manage electricity and avoid sparks or shocks. So these practices make sure excess electricity is safely directed into the ground. Helps mitigate risk associated with electrical hazards and static discharges. Yes, this means reducing the chances of dangerous situations like shocks, fires, or explosions caused by built up static electricity. Ensuring safe and efficient plant operations. When all these safety steps are followed, the plant can run smoothly without accidents or downtime. So that's all for the conclusion of today class. So we have discussed in detail about utilities, electricity and static electricity utilities. What are the introduction of utilities, objectives of utility management, what are the types we have in utilities, right? Cooling systems, electricity in process safety management, what are the electrical hazards in process industries, electrical safety measures, what are the measures we can take under static electricity in process industries. So sources of static electricity in process industries, control measures for static electricity. So and the emergency response and mitigation strategies, what are the emergency response and mitigation strategies, right? And finally conclusions. So this is what we have discussed so far, okay. So if you have any doubt, you can ask me online or offline, okay. Thank you all for listening. Thank you very much. We will meet next class.